Hi everyone, I'm Thomas, and I'm glad to be with you for this nice online meeting. Thank you, girls and guys, for the organization. So let me introduce you our very latest range of RGPs called Evo Rigid Lenses. It is a fact with this new range, we think we are able to fit any cornea with a very special lens. So let's see all the versions that are available. First, for the single vision, you have Orbiflex, the spherical design, Toriflex, the toric. It means bitoric and frontoric. You have the equivalent for compensating presbyopia. So it is multifocal, Boriflex and Toreliflex. You have a special design for the myopia control. It is Relaxflex Evo. And you have for irregular cornea, the FlexCon Evo, especially made for keratoconus. So many versions in one range with the same features to fit all the corneas. As you can see, the range of parameters is very large. So first, the base curve from 4 millimeters to 9 millimeters. The overall diameter from 8 millimeters to 11.9. The edge lift, where we will talk about it later. It is for the periphery, from minus 15 to plus 20. The sphere power from minus 40 diopters to plus 40 diopters. And the addition for the multifocal versions and the myopia control version up to plus 6 diopters. So very large range of parameters. To manufacture this very large parameters, we only use premium materials from the two most famous brands of GP materials. So Boston from Bausch & Lomb and Optimum from Contamac. And we will offer you materials with decay up to 180. So a very high decay. We know, for example, irregular cornea have a special needs, so we can offer it with a very high decay. For each material, we can provide different colors and at least blue or green and others depending on the material. And we are engraving all our manufactured lenses with the serial number. Let's talk about the Evo philosophy. It is a unique concept. It means the design always evolves with the base curve for the best. Actually, we have made many statistics about all the GP lenses we manufacture, and we have isolated some special features to provide you from the first trial the best parameter combination. To fit it, we suggest a very simple fitting rule based on K readings, and it is a two-step fitting. First, the base curves that controls the center of the lens, then the edge lift that controls the periphery. Do not worry about the total diameter. It just affects it does not affect the central fluo image. So when you have the right base curve, you keep it this way. And it only affects centration and movement. Otherwise, you do not have to change it. So this special concept allows you to improve your fluo image from the first trial, and it makes fitting much easier because there is even no need eccentricity to start the fitting. Let's talk about this two-step fitting. First base curve for the center and then the edge lift for the periphery. The base curves control the central fitting. Usually it is aligned to K, flat K. We always expect a low apical clearance, and the value of this apical clearance could depend on the type of cornea between regular or irregular. We will talk about it later. And when you change the base curve, do not forget to change the sphere so that the visual acuity remains the same. And you have the rule here. So for 0.10 millimeters of base curve, it corresponds to 0.50 diopters. Then the periphery with the edge lift parameter, it controls the peripheral flattening. It means the landing zone and the peripheral clearance. You have to get a smooth landing zone, and at the extreme periphery, thin to normal peripheral fluo width, as you can see here. So by managing these two parameters, you can really improve your fitting and increase your successful rate. For the first step of the fitting, you have to assess the base curve. When it's not a perfect fitting, we have these two types of result. First, for example, a steep base curve. Here you are the signs of a steep base curve. You will see pulling at center, moderate to strong landing zone, and it's not the principal sign, but you could observe normal to low peripheral clearance. It is here. So when you see that, you have to flatten base curve by at least 0.10 millimeters. So you do plus 0.10 millimeters. The other result you could have, it is a flat base curve. It means a low to no apical clearance, a smooth to no landing zone, and it's not the principal sign, but you could observe a normal to excessive peripheral clearance. So when you see that, here we have a central touch. You have to steepen base curve by at least 0.10 millimeters. So do minus 0.10 millimeters. Do not forget to change the sphere when you do that. The second step of the fitting, assess the edge lift, so the periphery. One result could be a steep edge lift. So it's not the principal sign, but you could have a slight pulling. But let's focus on a moderate to strong landing zone. So it is black in the intermediate zone. And at the periphery, low to no peripheral clearance, as you can see here. So when you see that, you have to flatten edge lift by at least 2 steps. So do +2. The other result, when it's not perfect, could be a flat edge lift. Sometimes you could observe a low apical clearance, but it's not the principal sign. The principal signs are a smooth to no landing zone, and usually an excessive peripheral clearance, as you can see here. The width is too large. So when you see that, you have to steepen edge lift by at least 2 steps. So do -2. And you can do this process for all the lenses of the EVO range. We have to divide the EVO range in 2 types. So let's start with the first type for the regular corneas. And first of all, the regular cornea with a low level of toricity. It means less than 0.3 millimeters. The first intention and the best option for this type of cornea is the Orbiflex Evo. The rule is very simple. Since you choose your base curve aligned to flat K, for the diameter, you do HVID minus 1.5 millimeters and just take the refraction sphere considering the vertex. Here you are the expected fluo image. So at the center, 10 to 20 microns apical clearance. So it is a slight apical clearance. A smooth landing zone. And for the edge lift, peripheral fluo width at least of 0.3 millimeters. We have also another version. It is called the asymmetric version of the Orbiflex Evo that could help you to fit intermediate level of toricity. We will talk about it later. So Orbiflex Evo is very simple to order when you log on pro.swisslens. You start with your K readings. So here 7.8 for the flat K and 7.7 for the steep K. For example, 0.4 for the eccentricity value, and a very normal HVID here, 11.8 millimeters. So when you see that and you follow the fitting rule, you will have to order Orbiflex Evo with a 10.3 millimeters diameter, a 7.8 millimeter base curve, and a standard edge lift to start the fitting. So when you log on pro.swisslens, select rigid, spherical design, and you will have at first Orbiflex Evo. So select it, and you have to choose your material, your color, and just fill in the diameter you want, the base curve, and do not forget the sphere. Let the other parameters as standard. Very simple to order. Then you put it in the basket and you can order it directly. Let's see how we handle other regular corneas, but with mid to high toricity. It means higher than 0.3 millimeters. You have to choose directly the Toriflex Evo Bitoric. It is a design with two base curves, and you just have to follow your K readings to fit it. So the first base curve is aligned to flat K, and the second base curve is aligned to steep K. It is the same thing to choose the overall diameter. And for the powers, you have two powers. Just take the refraction sphere for the sphere flat, and we automatically calculate the second sphere, the steep sphere. This automatic calculation will allow you to compensate 100% of the corneal astigmatism. So with a high level of toricity, it allows you to avoid misfitting in the second meridian and the tilt. You will have this type of fluo image with two dot marks along the flat meridian. And it is even possible to manage the periphery only in one meridian or differently in each meridian. So a very good design to fit perfectly high level of corneal toricity. Here you are the second type in the EVO range. It is made for irregular cornea and especially keratoconus with the FlexCon EVO. A design really made for keratoconus from the first stage to the final stage. To choose your base curve, you just have to get your steep K. We will advise you an overall diameter depending on the base curve, and also a sphere. It will be at first a statistic sphere. The expected fluo image, you have it just here. So at the center, we expect a slightly higher apical clearance compared to Orbiflex EVO. It means from 20 to 30 micron apical clearance. Actually, we just have to see the summit of the keratoconus, but not touch it. A moderate landing zone, and for the periphery, your fluo peripheral widths have to be higher than 0.4 millimeters. The FlexCon EVO is a special design with features different from Orbiflex EVO, for example. The back optical zone diameter is really smaller than for the Orbiflex EVO, and the eccentricity value increases quickly as the base curve gets steeper. And it evolves very quickly compared to Orbiflex EVO. So for a constant edge lift, for example, the standard edge lift, 0, if you steepen the base curve, for example here, from 7 to 6.8 and then 6.6, your landing zone and the peripheral clearance will remain the same. It is due to the special features of the FlexCon EVO. So you can really respect the two-step fitting. Focus first on the center to avoid touching the summit of keratoconus. And when you have the right base curve, then you can focus on the periphery and optimize the edge lift. Let's see some example of optimization with toric options. The easier one is when you have, for example, a residual cylinder. It means you have actually an internal astigmatism. So in case of poor visual acuity with a spherical lens, you just have to perform a cylindric over refraction, and this cylindric over refraction has to increase your visual acuity. If it is the case, it means you have an internal astigmatism that needs to be compensated. So just order the same lens, but with a front toric, in the front toric version to compensate it. And this lens will be stabilized with a ballast prism. So we expect the dot marks this time always along the horizontal meridian, but we can tolerate some small rotations up to 20 degrees. And we can compensate it on the axis on the lens after that if we observe that. Another example where a toric option could be useful, it is when you have a mid-toricity that you can see at the topography. Here you are 0.25 millimeters of toricity. So you think you can handle it with a full spherical design, but you should check the anterior elevation map because as we can see here, there is at the periphery there is a huge elevation difference between the flat meridian and the steep meridian. So here you are the result with a full spherical design. You have a toric pattern. So here the patient will not be comfortable, and you have a misfitting in the vertical meridian, and you could have tilt or upper decentration. So starting from this ambiflex evo with a base curve of 7.4 and a 9.7 diameter with the standard edge lift, just choose the asymmetric versions and customize the edge lift for each meridian. So we have flattened the edge lift on the horizontal meridian by one step, and we have steepened the edge lift by 4 steps in the vertical meridian, and the fitting is really better. Another very specific version is the quadrant version that will allow you to homogenize your fluo image. It will improve centration and physiological tolerance. So an example here that is still not perfect, but better than the first trial. So as you can see, the peripheral fitting is not perfect depending on the meridian with the -2 edge lift. So we have customized it in 4 different quadrants and increase it at 0 degrees. We have decreased it at 90 degrees. We have increased it at 180 degrees, and we have decreased it by 2 steps at 270 degrees. The fitting is still not perfect, but really better than previously. And as you can see, the physiological tolerance is better too, with no more keratitis on this area. And finally, how to compensate presbyopia with the EVO range. Actually, we offer the choice between bifocal or progressive lenses, and you will do the choice depending on the value of the addition, the patient expectations, and also the centration. For example, if you have a decentration, is maybe easier to have a good result with the bifocal one. And on the multifocal versions, we customize the front optic zone, what we call a ZOC. So at first, choose a center distance versions. Select the addition for a comfortable value, and for the ZOC, the external central zone, choose it so that it is smaller than the pupil diameter. If you need some advice, please ask us. We have some recommended values. So now it is up to you to try all this range, and it's up to you to master the green images. So thank you very much, and of course we have always here to support you, and you can bet on us to provide always new products and some education if you need it. Thank you very much.